Hello friends, welcome to Joy of Life. Today again we are going to look at the medium level problem of Leetcode, problem number 200, number of islands. So the problem is very simple. Given a m into n 2D grid map of 1 and 0, wherein 1 indicates land and 0 indicate water, return the number of island. So an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So basically, the problem says that we have a grid, something like this, and it consists of ones and zeros, and we need to find how many islands are there. So in this, we see there is only one island, that is this one. So we'll look at the solution, but I will highly encourage if you try to solve it yourself before looking at the solution. You can come back to this link anytime in future. First, it is always advised that you give it a try yourself. So let's look at the solution. So I have taken this in the whiteboard and let's see how we can do it. So over here, let's see how it goes. So let me get the pen. Yeah. So over here we can see that if I connect this so horizontally or vertically, so I can connect all of them at once. So this becomes my island. So there is only one island and that is this one. And so there are no ones. So all are connected with one. So the output will be one. There is only one island. Now coming to the second one. So if I see here, I can see that there is one island over here. So this is one. So this is connected diagonally. So we will consider only horizontally or vertically. So this by itself forms an island. Again here, if we take this one, so this forms one island because they are connected horizontally. So the output is 3, but we cannot consider if the diagonals are connected, we cannot consider them to be an island. It has to be connected horizontally or vertically. So the problem is very straightforward. We are given with a array and we need to come up with uh, the integer, the number of islands. So let me clear it off and get this again. So we'll now see how we are going to approach this problem. So if if I have this two-dimensional matrix of size 5 and 4, okay. So let's create the matrix. So we have something like this, which consists of 1 and 4. Okay, so let me put the values over here. So let's use the second example. We'll see both the example getting covered with 1. So we have a 1 here, 0 here, 0 here, 0 here. We have a 1 here, 1 here, 0, 0, 0. Then we have 0, 0, 1, 0, 0, and then 0, 0, 0, 1, 1. So as you know that the indexing system starts from 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 1, 0, 1, 1, 1, 2, 1, 3, 1, 4 like this, right? These are the this is how we are going to access our grid array, two-dimensional grid array. So what we'll do is we'll start from 0, 0 index. So basically we'll have two loops. So the loops will start from so I'll just traverse the entire entire dimensional matrix, and we'll see how we'll get to the solution. So this is I not, yeah. And so whenever we find that grid ij is 1, that means we have started finding, we have stepped into an island. So so here at the first index, we see that we have already stepped into an island. The value is 1 over here. So now what we'll do is sitting at the index. So let's say for sake of simplicity, I'm creating a small array over here to explain the thought process of how we are going to solve this problem. So suppose you encounter a 1 over here. So we are told that we can check both horizontally and vertically. So it can be either this way or this way, right? But not this way. This is not allowed. These are correct. So what we'll do is whenever we encounter a 1, we will try to see its north, south, east, and west, all the neighbors. So this becomes your solution. So whenever we encounter a 1, we try checking all the boundaries. So when I am over here, I'll first go to its right and check, and then go to right again, and I hit a 0. So I know I cannot go any far from here. So we'll come back to this cell, and now top we cannot go. Left is where we are already coming from. So these options are negated. So the only option for me is to go down. So I go down. So I am here right now. I go right. I see this option is not available. I check up. This is where I'm coming from. So I negate this. I go left and I see, yeah, there is another one. So I am here now. So I check right and see that this is where I'm coming from. I go top. I see that it has already been visited, so it is discarded. I check left. I go out of bounds, so I negate this. I go down and see a 0. I negate this. So basically, starting from this first position, what we are doing is basically we are trying to check all the neighbors and then going into the depth. So basically, we are talking here about a recursive solution. So we are going to recurse on this. So we have talked about few of the cases over here. So if grid equals to 1, then we are going to consider this. And if it is 0, we are going to come back from it. So let's see how our solution comes into shape. So we will go back and forth between the code and the whiteboard. So let's go to the code. So basically we have been given a grid, which is a char, two-dimensional char array. So first things first is like our grid, the boundary check should be done, part of good coding practice. So in this case, we don't need to do anything. We can just simply return 0. Okay. Now we need to count our island, which is initially is set to 0, and which at the end will have our final result. So we are going to return this count at the end of our processing. Now let's break down to the solution. So what I need to do is to iterate over the entire array. So I will start from 0, 0. So I'll start from basically this. So if I put the index over here, So I'll start from 0, 0 and then go row by row. Sorry, the lines are not correct, but anyways, you got the idea that we are going to go row by row. Okay, so coming to this, we'll go by the length, and so int j equals to 0, j let's then grid dot, sorry, I have to take that particular index. Okay, so basically we are just going row by row. So let's print it out and see what your I and j points at. So let's do a system.out.println. So let's do a system.out. Okay, so after the row printing is finished, so what I'll do is just to show you, just going to, okay, so we are just going to run this code. So this will run with this example. So you can see here that 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, and then followed by next row 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 2, 0, 2, 1, 2, 3, 2, 4. So anyways, don't go by this result because we are not done yet. So let me get rid of this line. Okay. So now what we are going to do is we are going to check the grid, and what we are going to do is we are going to start from the first 0, 0 element and then go down. So just now while we are looking at the whiteboard, here what I said is that we are keeping a track of the visited. So let me draw this grid once more again for you. So I'll just draw it a miniature version of this. So let's say I have island over here and rest all is 0. So my strategy is to first, let's say I'll go first left, then I'll go, or let's go by, yeah, let's say we'll go to east first. East means left. And then we'll go to south, which means down. Okay. And then we go to west, means right. And then we go to north, which means up. So this is basically starting at this index. This if this is my cell. So first we'll go this one will be first, then we'll check this one. So we'll go and check this one third, and this one at the end. So it might happen that we in this case over here, so we start from here, go left, then go down, then go left, and then we try to go up, and we have already visited this, right? So we need to keep a track of what all we have visited since we have started. So what we are going to do is we are going to create a Boolean array. So a two-dimensional Boolean array we need to create, and we can call it discovered. So as you know, when I'm initializing, it will all be set to false. So I'll say grid dot length and grid 0 dot length. So so what I did is let's go back to the whiteboard once again. So let's say we have say we have this input. So for this input, what we did is we have created a new Boolean array, and we have set everything to false. So this is the state of our array at the beginning. So on, so it's, yeah. So this is how it looks. And we are starting from this index. So we are interested only if this has not been explored previously, so it is not discovered. So that is my first case, that this cell that I am currently at is not already set to true, it should be false, and the cell where I am in the grid should be 1. So it's a char array, so I'll just put it in the. So what are we checking? We are checking the both discovered array and the grid. So this is my grid, and this is my discovered array. So if I am at say 0 0, so let's get this. So if I am at grid 0 0, so it has to be 1 for me to consider going with this strategy. If it is 0, I know I'm in water, I don't need to check it, right? And second thing that we need to check is that it has not been explored earlier, so it should be set to false. So that's the condition we have given over here, that it is not discovered, means it should be false, and the grid value where we are, the particular cell, should be set to 1. Then only we are going to consider this. And now what we are going to do is we are going to do a discovery. So let's say this method as discover. So in the discover method, so in this discover method, what we are going to send, we are going to send the grid that we got as an input, and we are going to send our discovered Boolean array to keep a track that what has been discovered and or not, and also the row and column. So we are sending ing. So one thing to notice over here, as soon as I am inside this, that means I have stepped into a cell which is not discovered and which is 1. That means that is definitely a island. So in this case, first I will increment my count, right? So let's take a corner case scenario if there is nothing. So for example, um, let's take a 3 by 3 small one. So if I have a 1 and 0, so the moment I discovered this 1, that means it is an island, because my grid says that everything is set to false, and we see a 1 in the grid. That means it is definitely an island. So we will increment our island count. So we'll increment our island count. We'll do a island count plus plus. So here we are calling it as count. So we are just putting it as count plus plus. So here we have created a new method which will take care of the discovery. And what this method will basically do, that we have already talked about. So this method, so first input is our grid, okay, and then we have our Boolean array as, sorry, as discovered, and we have our ing, right? So I know when this method is called, that I am in a island marked by 1. So what I am going to first say is that when I am stepping into a cell, first suppose we are calling from here with 0 0, right? Where I is 0, j is 0. So first thing for me is to mark this discovered as true. So first what I do is I update. So when I'm called with these two values over here, so let's say it was called with this value. So first thing that I should do is to change this false to a true, right? So that's what we are doing over here. We are setting it to true. And now what we talked about, we will do a further discovery. So first we'll go to east. So I'll say explore east, explore south, explore west, and explore north. So when I say this, so basically what I mean is I'll just call the same function again with grid and discovered. So you can see here that we have before calling the method again, before going into the recursion, what we did was we set this discovered to true so that this cell is uh, not visited again. And now we need to, so we are going to the east. So I remains at I and j remains at j goes to j plus 1. So this becomes my east. So you can see that I am just incrementing. So if I am at 0 0, the next thing that I'll check is 0 1. So if you can see here that this is my 0 0 and this is my 0 1, this cell. So I am just incrementing the j. I remains at 0 and I am changing j. So next part will be to discover south. So I'll go to south. So when I go to south means I'm incrementing one row and I stay in the same column. So when I say south, basically I means this cell, which is 1 0, right? This is the index 1 0. So this is, so if I put it over here, a 3 by 3 matrix. So this is my 0 0 0 1 0 2. This is 1 0 1 1 1 2, and this is 2 0 2 1 2 2. So in this case, I am incrementing I but keeping j constant. So my south discovery is done, and now I go to my west. So discover, again same thing, grid and discovered, and this time I am going to west. West means I will be decrementing and j remains, no, I will remain at the same level and j will be decremented, right? So in this case, what will happen is we will go, if I'm sitting here, so if this is my ideal candidate, so I'll be going to this one. So 1 0. So I remains at where it is and j is decremented by 1. That's what we are doing. I at same and j is decremented by 1. And similarly for north, so I'll say discovered, and this one will be I plus 1. Sorry, I minus 1, because we are moving up one row and j stays at the same level. So over here you can see that I is decremented from 1 to 0, but j stays at same same value. So now we have our all the discoveries. Now as you can see over here, right, we did not do the validations yet. So if I am over here, my north and my west will take me out of bounds, right? Which will eventually cause an exception. So we can't afford to do that. So we have to prevent that. So we are going to add checks for that. So whenever this function is called, so a basic check that I would like to do, I should not be less than 0, or I should not be greater than grid's length. So it should not be greater than equal to the grid length. So if I have two elements, it should not go to the second index. So it should be 0 or 1, right? And same thing goes for 0. J should not be less than 0, and J should not be greater than or equal to grid I dot length. So if any of this condition is matched, so what we'll do is we are not going to process it any further. We are just going to return it. Okay. So these are basically my bounds checking for grids, row and column. Okay. So apart from that, a few other checks are also important. So what if the grid is already visited? If the grid, if the cell is already discovered. So we are going to make sure that if discovered I of j, so here we are updating the discovered array, right? So if I get a true over here, that means this cell has, though it is in the boundary, but it has already been visited. So there is no way this cell is going to get considered because it has already been considered. So in that case also we are going to return. We are not going to process any further. So over here you can see, right? So let's say we are in a 3 by 3 grid. Sorry, let's put it to 1 and this to 1. So when I am here, when I try to, so I started from here, I came here, then I came here, then I came here. So when I go north from here, though it is a valid index, but it has already been explored. So that is the check that we are putting here. If the cell is already discovered, we are going to discard the processing of it. And another case, if it is water, if it is water. So what does that mean? So if my grid ij is 0, that's a simple check, right? So basically when you are, let me draw it again for you. So when you are having a matrix grid like this, when you go to the east from this cell, so what you hit is a 0. So you are not considering this. So you want to discard, means there is a disconnect and you don't want to go any further in processing. So you want to step back. So that is what we are doing over here. Okay. So this is the code. This is our final code. So this will be done. So you can see that every point we are we are updating the discovered Boolean array. So if there is a disconnect, so for example, let's take the example from here, this example. So when the processing starts, so we are at this cell, we go to this cell. So what happens is we are updating all. Then from here we came here, and from here we came here, right? So what happens is these four cells are marked as true. So what will happen is, let me draw the, so 5 elements, yeah. So what will happen? These will be marked as true. After the first, assume that the empty ones are false. Okay. So we started with from the index 0, 0. So what will happen is now when we reach this cell, there is no other possibilities. This is 0. This is is already explored. This is already explored. This is out of bound. So next time this loop will this loop so first time it was called with 0, 0. So we started from here. So next time it will be called with 0, 1. So when we get a value, a grid value of 0, 1, so what I'll check is that is it marked as true in my discovered map. So I'll see that it is true. So I'm not going to process it any further. So it will be skipped. It will not be considered. Again, we will encounter a 1 at the index 1, 0. And this will still not satisfy because this is true, this is true, so this will also not be satisfied. So the next place where it will be satisfied is grid 3. um, so this where will be the condition will be satisfied at 0, 1, 2 and 0, 1, 0, 1, 2. So it will be satisfied at 2, 2. So when it comes to 2, 2, it will mark it as true. So what will happen is when it will mark it as true, it will increment the island count. So for all these, it will not go ahead and increment because we have already marked the Boolean map as true. So it will never get in, this if condition will never get satisfied. So only when we discover a new island, that means the grid value is 1 and the discovered Boolean array at that cell is at false, then only we are going to increment the count. So this will safeguard our overlapping problem. So when we have connected islands, it will be solved with that. I hope you got the idea of how we are trying to do, break down the solution using the simple recursion kind of algorithm. So let's run this code and see what result we get. So you can see that it has been accepted. So let's do a submit and see how it goes. So you can see that it has been accepted. It has a performance of 3 milliseconds. Of course, here and there we can do a lot of improvement. But what I mainly wanted to focus is on the algorithm and the approach that we have taken to solve this problem. Hope this has cleared up quite a few doubts that you have on how to solve this problem using recursion. So do like, subscribe if you haven't done so, do share with your friends. I'll be doing more Leetcode problems in the days to come. I've been trying hard to do at least one problem every day, though I have a bad cold, so I've been coughing here and there. But yeah, I'll try to come up with more videos. Thank you for watching it. Hope to see you guys again soon. Have a great day. Thank you.